The alternating series test is the test you can use if your series has terms that alternate in sign. And the terms alternate in sign means that they go plus, minus, plus, minus, plus, or minus, plus, minus, plus, minus, plus. And so the series will look a bit like this one here, or this one here, in which I've added 1 to the exponent on the minus sign, which means that it starts with a plus. So this one starts with plus, and this other one starts with a minus. Okay, so the alternating series test says the following. If you ignore the sign for a moment, that's what the bn's are. If all the bn's are positives, that means ignore the signs against. That's condition 1. If all the terms are monotonically decreasing, they get smaller as you go, and they have a limit of 0, then your series converges. As usual, the test doesn't tell you the actual value of the series. Sorry. But, okay, it tells you if it converges or not. Now, 2 terms that we often use is if the series converges without the minus signs, so if we have an alternating series and this series also converges, then we say this series is 1 n plus 1 or not is absolutely convergent. Otherwise, we say it's conditionally convergent. Essentially, it is conditioned on the minus signs. So to give you an example of a series that is conditionally convergent, we have the alternating series, the alternating harmonic series. The harmonic series we know diverges, but here's the alternating harmonic series, and you can see that the alternating harmonic series has signs that switch, plus, minus, plus, minus, plus. We know the harmonic series diverges. The alternating harmonic series actually satisfies all the conditions of the alternating series test. Taking a look at this is positive. So ignore the sign for the moment. That's condition 1. It's monotonically decreasing. Because 1 over n is greater than 1 over n plus 1. So that's 2. And furthermore, the limit, as n goes to infinity, of 1 over n is 0. That's condition 3. So this converges, and it's a conditionally convergent series. Convergent series. Okay. Let me give you an example of a situation where the series is an alternating series, but it does not converge at all. So this series here is an alternating series. But if you look at it, you say, well, each of these pieces are positive. They're monotonically decreasing, but 3 fails because the limit as n goes to infinity of 2 minus 1 over n is 2, not 0. Okay. Now, why does the first one work and the second one doesn't? Let's just take a quick little digression into why the proof works. So if we look at the alternating harmonic series, how does it operate? Well, if I draw a number line, the first term is 1. The second term is 1/2. So if I look at the first partial sum takes me to here, which is 1/2. I went down by 1/2. The next term in my series is a plus 1/3, so I go up, but I don't go up so far as this one here. I can't exceed it. Why? Because my series is monotonically decreasing in these terms. So that's 1/3. My next partial sum is here. After that, I subtract a 1/4, so I go down, but I can't go so far down as here, again, because of the monotonicity. And so each time I add on another term, my partial sum keeps getting squeezed tighter and tighter and tighter. It cannot escape. And so you have a limit on the partial sums. And that's why the alternating series test works. Of course, you can see that in particular that condition 3, if it doesn't limit to a 0, then the partial sums are not necessarily trapped, and so you might not get convergence. In fact, that's pretty much what happened right here, is that if I look at the partial sums, eventually, well, there's a whole bunch of terms, but eventually it's approximately plus 2 minus 2 plus 2 minus 2 plus 2 minus 2 as your n gets really, really, really big. Now, you might say, gosh, looks like all those 2's cancel out, but it's conditioned on how you choose to add up your 2's. And the way that the partial sums come here, they're plus 2 and then minus 2, plus 2 and then minus 2, which means that they never stabilize to any limit. So actually, partial sums here do not have a limit. This series diverges. So the alternating series test is a good one to remember, and if you happen to see an alternating series, go reach for it. It'll probably be way easier than any other test you might try.